Hello, and thank you for joining us for our latest AMS Livestream. I'm Nick Holt, editor at AMS. For this session, we were looking closely at how automotive paint shops are becoming more flexible and sustainable. And to offer some insights, joining us today on our expert panel are Henning Steinborn, head of paint shop at Porsche's Leipzig plant, and Klaus Koberg, who is head of paint shop maintenance at Leipzig. Also, Sebastian Salz, who is automotive marketing manager at equipment supplier AMS Kremlin. Now, sustainability is a key driver in developing automotive manufacturing processes, and nowhere is this more important than in paint shop operations. So today we'll be discussing sustainable strategies, waste management, reduction of energy consumption, and how the use of more sustainable materials is affecting these operations. We're also looking at some of the projects that are out there that the guys would like to talk about as well. And if sustainability is a driver, then digitalization is probably an important enabler. And we'll be looking at automation, quality control, predictive maintenance, and leveraging a lot of the machine data that's now being made available. Now, our agenda for today is we were going to have some one-to-one sessions with our experts. So to begin with, it will be with Henning and Klaus from Porsche, followed by Sebastian from AMS. When we've concluded those, we'll be going to a Q&A session, a panel session with all of the speakers. We would welcome your questions, so please feel free to send them over to our experts, and you can do this in the chat box in the bottom right hand side of your corner there, and we will attempt to answer as many of those as we can. Before we begin, I'd like to thank our partners for this live stream, AMS Kremlin and Jayco Kaikisha, for their support. And one quick mention as well, we are launching a new event later on this year, in December actually. You can see the dates there, the Evolution Summit Live, and we'll be looking at some of the key topics across all of the automotive industry, manufacturing operations across the automotive industry. And we'll be having a number of key speakers from tier suppliers, OEMs, equipment suppliers, and some specialists and analysts involved in that as well. So please join us for that. Free to join in, free to sign up. We'll be putting a link, I think, in the chat box, so you can access it there, or you can access the link and register via our website. Right. So let's get the panel started. So I'd like to welcome onto screen Henning and Klaus.
Good afternoon, Nick. Thanks for having us. And good afternoon to all of you, wherever you may be.
So Henning and Klaus, you've got a quick presentation around Leipzig to do. I shall just camera off, and then we'll come back after you've done your presentation and have a bit of a chat about operations there.
All right. Yeah, thanks, Nick. Just very briefly, really to explain to you where we are and what we do when we're not doing live streams. So Porsche Leipzig, Nick, if you go on the first slide, please. Porsche Leipzig is based in the far east of Germany, far away from our mother factory in Stuttgart, where the home of Porsche is really. We have been around for 20 years now in Leipzig. We are a production facility only, so it's roughly 4,500 people building cars. We started with the Cayenne in 2001, had the Carrera GT, our super sports car, from 2003 until 2005. We then introduced the first Panamera generation, and since 2013 we have the Macan, our small SUV. And I think, Nick, if you go on the next slide, you should see those two cars that we built today. Cayenne has left Porsche Leipzig, is now built elsewhere in the VW world. Last year we've built 78,642 Macan in the 8th year after SOP, so still going very strong, very high demand for that vehicle, and Panamera is 21,000, so overall 100,000 units a year. We can do 550 a day, and that's exactly the number we are currently running. So even though there's lots of trouble in the world at the moment, Porsche Leipzig is going strong, and we plan on continuing just so. Next slide, please, Nick. We are a big factory. We are right next to our racetrack. In the bottom corner, you can just make out a few of our nice 911s and Panameras and all. We now have one final assembly, which is in the foreground of the picture, and then in the background, you can make out our paint shop and also 3 body shops. So Panamera body shop, Macan body shop, and then the Macan Electric, which is going online just now. The paint shop has been around for 8 years now, so it came with the SOP of the Macan, was the first model we started building completely in Leipzig. And so just as a quick overview, I brought 2 examples regarding sustainability, but also digitalization, which I would just briefly like to touch on. I think we're gonna touch on those later on. So this year we introduced an automatic defect detection system in our paint shop just before the final inspection area, which has gone online this summer, which is working very well, which is one good example of digitalization. We'll pick up on this later. And then a quick video on something we introduced already with the build of the paint shop, which is the Eco Dry Scrubber, which we use to get all the overspray out of our air in the paint shop. And we have a short video explaining how it works. That was state of the art 8 years ago, and still meets our requirements, and is still a very good system for us. So Nick, if you can just play the video so the audience can see and understand what we do and how we do it. Basically, we have air moving through the cabin, which collects the overspray, which is blue in this video. This is then mixed with limestone powder, rock flour if you like, which then collects the overspray. This rock flour is then filtered, and once we get rid of the rock flour because it's saturated with enough paint, then we use it as fuel for a cement plant, which is close to the factory. So it's not waste, it's being used to do stuff down the line, really. So 2 examples, and I think Nick will mention those later on. All right?
Thanks for the presentation and the neat video there. Very good to see how that works. I think the audio is perhaps masking your voice a little bit there, Henning. So we might get you to explain that again, how that works without the video. I mean, we're looking at overall paint shop development for sustainability, and you mentioned there capturing the overspray, disposing of the waste materials as sustainably as possible. Have you? And it's a relatively new paint shop in terms of, you know, I mean, some paint shops have been around a lot longer than that one. I think when I visited Leipzig, when Macan was just about to come online, the paint shop wasn't there when I just joined. It was literally about to start production. Have you implemented any other sort of sustainable strategies in the paint shop aside from the waste collection there to try and sort of mitigate kind of waste and help with waste management, and similarly with sort of energy usage as well? Because I mean, paint shops are notoriously energy or hungry, and I know there's been a lot of development in that. Have you implemented any sort of strategies or technologies at Leipzig aside from what you just described?
So I guess our overall strategy in Leipzig is to look at everything, really, at all the processes, starting from front to back, really. So it's something we do on a normal basis. So it's not something that we have a strategic outlook on and have big strategic projects. It's more the continuous improvement, as you like, to look at energy consumption, to look at waste, to look at renewable energy, stuff like that. We have a few examples which we can mention if you like. Klaus, maybe if you want to elevate on some of the stuff we do around waste and energy consumption.
Energy consumption in general reduce it during increasing the recirculation in the spray booth from 80% better, or in this case to 90%, so that we can reduce the cost for the fresh air. This is one thing. For the waste of the phosphate, we try to dry it so that we can reduce the rest water in the waste.
Good.
And one of something that that intrigues me a little bit was when you're implementing strategies to reduce energy consumption and waste, but particularly around sort of energy consumption drying. You mentioned the phosphate there. I always wonder, is it a challenge or an opportunity kind of situation? Is it a challenge when you're applying these things? Does that actually help you in terms of improving sort of cycle times and efficiency? Does that kind of development lead into that kind of benefit?
Die Frage, ob wir das separat voneinander machen oder ob das uns hilft, auch die Taktzeiten und so weiter besser zu machen.
This is nothing for takt time. This is only for energy reducing or waste reducing, and therefore we make every year single projects. So every year we are working on the items, different items, so that we get forward.
And
since the last 8 years, we have reduced 10% of energy, and because it's a new paint shop, 8-year-old, but relatively new, and 10% is much.
Yeah. In terms of kind of, well, I'll come on to the quality control cameras in a minute, but just looking at the maintenance of the paint shop, do you use sort of predictive maintenance data from the systems in there to sort of mitigate any sort of downtime or bottlenecks? Is it how? I mean, I've heard of it across other parts of the manufacturing operation, and obviously turning objects, etc. But I just wonder, within the paint shop, is that something that's been of use to you, and have you found that that's helped? And I'm guessing the knock-on from that is the more efficient you are, that must help the sort of sustainability side as well.
Predictive maintenance. So yeah, we're starting to look into this. To be honest, it's still something that we monitor more than we actually do use it. From our point of view, there's a few good systems that we started looking into, but it's nothing that we use on a overall basis in all areas of the paint shop. We're starting to use pumps that are
vibration analysis on pumps and ventilation systems we have for throughput improvement, and also what we now try to do is current control for detecting mechanical damages in the conveyor systems. Therefore, we are working on.
So it's the first couple of items that we start using. So vibrations, Klaus said, on pumps to see whether there's any abnormalities, and conveyor systems as well. But I'm not quite sure. I think there's more to be made, but we are still at the start of this journey, I guess, I suppose.
Yeah. And I mean, I think Sebastian actually might come on to some of the sort of maintenance around and the monitoring of pumps, etc. later on. But I mean, in terms of sort of smart systems and digitalized systems, I mean, I've seen smart drying systems for the paint. So it kind of localizes where the heat's applied depending on the body. Is that something that you haven't used, or is it something that you might use? I mean, do you see a lot of scope still to make the paint shop more efficient than it is at the moment?
So maybe in general, we started 8 years ago with a new paint shop, and all the settings in all areas are basically the default supplier setting. And one example, in the spray booth, we have the air running through the cabin to collect all the overspray. That was a setting that we started with, and then later we found that in this setting it wasn't taken into consideration the size of the body shell. So we actually used too much air in the cabins. that we changed because we now use the footprint of the body shell as well to make sure that we reduce the amount of air we need. So that's basically one example. Another example being in our dryers that we, at the beginning was, once we start production, we turn it on, and once we go home, we turn it off. So it was an on-off setting. Now we have sort of a cascade in the turn-on cycle. So we start at the front of the dryer, and then we go towards the back, so to make sure that it's only up and running once the first body shells do actually arrive. So that sort of thing, improvement of the overall process. The basic process is good, but then we start fine-tuning the parameters and all the variables that we can adjust. That's obviously nothing you just do once and that's it. You have to do it all over again once you get new bodies and new production numbers, volume, etc. So it's an ongoing process, really.
Yeah, and you mentioned earlier on that it's lots of small things that are combining together to create that. Yeah. Just go into a couple of processes that you mentioned earlier on about the cameras for quality control. So sort of post, could you just talk a little bit more about that technology? How long it's been developed and what benefits you've seen from it?
Absolutely. So there's two basic difference in the systems. One is a static system without a robot. It's just cameras in a tunnel, really, that takes pictures of the paint surface. Our system is a bit more complicated. It's two robots. You may have seen on the pictures. Two robots on a 7-axis, so they can move alongside the body shell. And then it's a couple of cameras, 4 cameras, and a light source, which puts light patterns on the surface. And then every 2.5 millimeters, we take a picture, which is roughly 100,000 per body shell that we do. So it's 100,000 pictures in 72 seconds cycle time, which then is being analyzed in another 30 seconds to then show us where we have, not only where we have a defect, but what sort of defect is it? Is it a pinhole? Is it a dent? Is it a run? Is it a whatever? Basically all standard paint defects we can find and then communicate to our workers on their screens that we then have in the light tunnels, in the inspection tunnels later on. So the system that we developed, we had the hardware in our paint shop last winter, so last Christmas really. And then we had half a year to get it up and running for our current models, which was a small team of 4 people working on that together with our supplier, which worked quite well really to have him here on site and get it going. And since this summer, so for maybe 2 months, 2.5 months, we have it now up and running. And so far, very, very good and reliable system. And it's also good because we can use the data. We're starting to use the data to go into the process steps before the actual defect detection to hopefully then have a closed loop regarding where do we find defects and where do they actually come from. So yeah, a very good system, which we then now can use for the future models as well, which is basically just the reprogramming of the robot movement, and that's about it, really.
Do you know if that's, or can you say if that's been rolled out across other parts of the Porsche network?
No, so far we are the first in the VW world, so there's no other factory in the world, in our small VW world really, that uses this system. So we've got lots of visitors coming to have a look and understand why we think, and we're quite convinced that this is a very good system and maybe better than the tunnel version, the static version, as we call it. So
if I remember rightly, Porsche also unveiled or revealed a new sealing process for the bodies last year, potentially. I can't remember if it was last year or earlier this year. Is that something that's been implemented at Leipzig?
Do you mean a new application process or new material?
New application process.
In Porsche Leipzig, we have a standard application process. We looked into direct printing, digital printing of sealant, but that so far doesn't work for us because our material is different. We do use a low density sealant, which saves weight and also obviously then makes the electric cars go further. That's something that we implemented a year ago, which you won't notice because it looks and feels the same as the standard sealant that we had before.
Yeah. Okay, well, I think what we'll do is we've got a few more questions lined up for you later on. So we'll say thanks very much so far. I'll bring on Sebastian. Okay.
All right, thanks.
Thank you. So we'll catch up with Henning and Klaus in the Q&A session. But yeah, I'd like to welcome Sebastian Salz from Summit Kremlin. Hi, Sebastian, how are you doing?
Very fine, thank you. Hello, everybody.
So again, you've got a short presentation discussing a few things, and then you and I are going to have a chat when that's finished. So I'll just camera off and mic off. I'll let you get on with that.
Thank you, Nick. Welcome to everybody. I'm very glad to be here to present shortly the company and the latest technologies we are providing to the automotive industry. So AMS Kremlin is part of Excel Industry Group, which is a French-owned company in gardening, spraying, in agricultural and garden. And we are in the industrial division, around 900 people working on spraying, sealing, bonding in the industry. Half is for automotive. We are present in 15 countries, and our main headquarters is in France. We have 2 factories in France, and we acquired Intech from Eisenman Group 2 years ago. So we have a factory in Germany, near Cologne. And we have also big subsidiaries available in China and USA, for Asia and America, to provide engineering services with a lab, with robots, with skilled people for technical projects. And where we are providing equipment in the body shop first, for gluing, for adhesive dispensing, pumping. So on the right side, yellow. We are also in the paint shop for sealing, sound deadening, from the pumping stations to the robotic application or manual applications. And of course, on the paint, where AMS Kremlin born a few decades ago for spraying the paint with the robots. But we have also the paint circulating systems, pumps for that. And in the trim shop, we have some equipment for the windscreen, the windshield gluing system. And of course, on powertrain and battery, we provide some pumping and dispensing systems. And for tier 1s in plastic or metal parts, we can also provide these pumping and dispensing and painting systems for plastics and wheels and many parts. So you understand where we are, and few samples of our equipments, from the simple, let's say, automatic guns, which can be used for the black seal or for the underbody coating, to the bell sprayers for the paint coating. And of course, we have to dose and to supply all these materials as viscose or liquid it can be, to change colors for the paint, to dose very accurately the sealant. We have all this equipment. And I wanted to have a last slide about the latest technologies, innovations we propose. to save paint. First, the paint save system. It's a system which is between the color change block on the robot arm and the sprayer on the robot wrist. We can reduce the paint lost during each color change. So we are only 15 cc of paint lost. On the lower left, you see the external charge bell sprayers for interior painting, which is a more economical and easy to invest and to install a system compared to the traditional and high efficient internal charge sprayer. On the lower right, you see the electric pumps, which brings a huge energy reduction compared to pneumatic pumps. I can give you a few numbers later. And the latest one is digital printing. Instead of spraying, we could print. So it's under development project, and it will be released next year. So if you don't have any overspray, you increase your transfer efficiency by 30–40%. So you save paint, you reduce VOC consumption also in your paint shop. Not talking about all the savings you have all around the printers, in the booth, energy, air. We talked about a few minutes ago, the air ventilation. If you reduce a little bit, it's huge savings. So when you print, you don't have overspray, so you don't need 0.3 meter per second in the booth of air ventilation. 0.1 is enough, and you don't need to use so many fresh air. So it's a huge thousands of euros, of hundreds of thousands of euros per year per paint shop that can be saved for that also. That is my overview of in few slides to start the discussion with you.
Thanks, Sebastian. Question I've got really is, as a supplier working with sort of OEM and tier supplier clients, where is the sort of greatest demand coming from in terms of your automotive customers? I mean, in terms of sustainability, is that a big criteria now on the equipment that you're selling? And we mentioned, I think you and I spoke about it, we mentioned it a little bit with Porsche, sort of this idea of digitalization in terms of the monitoring, the data gathering, that sort of thing. But in terms of demand, is there a particular area, or is it just across the board?
As a manufacturer of spraying equipment, we were already involved in both of these demands for decades, because as we design our sprayers to be more efficient, meaning less running cost, higher transfer efficiency, higher lower paint lost. That means that we are already in being efficient is being also sustainable for the sprayers. And for the digitalization, we already have to control all our equipments. So we have to control if we continue to speak about the bell sprayers, we have to control the bell speed, the high voltage tension, the flow rate. So all these parameters are monitored and controlled, and so easy to monitor, available already on to any kind of big data lake who can record all these parameters and feedbacks from the equipment. So these both raising demands are in the DNA of the products we are designing for decades.
And you're right, absolutely right. I think when you and I are discussing, I mean, if you think about it, environmental challenges have been around for decades in paint shop. I mean, to reduce the costs, energy consumption, material consumption is an ongoing thing. I think the issue we're seeing now is that it's being raised to a level where the transparency of the supply chain is now very important. So suppliers and OEMs themselves are having to kind of demonstrate and actually implement a lot of these things that maybe are on the back burner, but it's become it's like how the priorities sort of roll around and go up and down. So, and it's interesting because, as you say, you've been working on a lot of this, like the efficiency of the paint transfer for a long time. So would you say that, I don't know if this is the correct term maybe, would you say that you're keeping pace with the demand for this kind of efficiency? You have been and you still are keeping pace with it in terms of the equipment and delivery systems, in terms of the technology of those?
Yes, we keep to work on that, to improve. And the last slide about the latest innovations are still in the same way to reduce the waste, reduce the paint consumption. So our partners, paint manufacturers, are not always happy about that, but we are reducing the paint consumption thanks to the equipment. So it was a wish from every OEM, every industrial company who has to reduce the cost, and the cost is the amount of paint also. So it goes in the same way for us, so it's great. I think that's also maybe why we have this green color, type of green color in our company, because we are not so green because we are painting, but we are painting with the most efficiency possible with the technologies we are developing.
And I mean, paint shop's fascinating because it's a very unique process within the car build, and it's the very nature of it makes it quite challenging to reduce consumption, to get the finishes they want and to get the throughput. One of the things we've seen across tier and equipment suppliers at the minute is that as the need for other technologies, greater depth of competencies is coming, they're acquiring or partnering with other companies. Has that been the case with Samis Kremlin? Have you had to embark on any joint ventures, or have you done any acquisitions?
Yes, in the last 2 years we acquired 2 companies. The one I said, Intec, for the gluing equipment in body shop, which is a German company with a great team of 100 people in Cologne, and they join us to increase or to help us to provide latest technology for gluing in all of their paint shop. They are working with great German OEMs, and we are opening doors and of other OEMs to test and validate these technologies. So a great team joined 2 years ago, and last year we for the digitalization of printing, so digital printing, sometimes we say, we acquired a very small company in Germany too, as well, end of 2020, to get a new technology for printing. And that's the one we are developing and we will launch next year.
Yeah, we'll probably come on a little bit to that later on. I think it's interesting. It's an interesting technology, and I think I mentioned to you when I spoke to you, the last time I saw two-tone cars being painted not that long ago, they were still masking up with paper and tape and being taken off the line and reintroduced, which is, so it's especially it seems more popular now as a customization. I don't know if you can, on the basis, obviously you mentioned the print tech system. Have you developing beyond that? We can talk a bit more about that later, maybe. Are you developing any new completely new paint shop technologies? I think the reason I asked that is because obviously, as you say, you're all constantly developing your product range and your systems, and you're meeting then the requirements and expectations of customers. But I wondered if you were looking at the market, looking at what was happening out there in the trends, and if you're looking at developing and adding in new systems or something that's not off the shelf, essentially, that is new, completely new.
So we of course we have a strong discussion with the paint manufacturers and the material, the sealant and adhesives manufacturers. And so we have to continue to replace and renew the existing equipment. So next year also there will be a new range of bale sprayers coming on the market. It's our 8th range. So you see how long we are designing rotary bale sprayers, and it will be a great product. I cannot say so much, but it will be a great product to adapt to any kind of particular process which could raise in the coming years. I think we will maybe speak about later, but one of the big trend is having a low bake, very low bake process, meaning decreasing the temperature of the ovens. We reduce the number of ovens, but we have to cure at high temperature for the sealant and the paint. For the paint, the paint manufacturers have already the paint who can be cured with a hardener, with a 2K process. We can reduce the temperature, but still the sealant has to be cured as well. So it's still a challenge for them to find the right sealant. And for that, to manage 2K, so hardener mixing with a base, we will launch sprayers who can make it even more efficiently.
Yeah, I know. Speaking to the paint developers, the coatings developers, that low bake paint, low cure paint, temperature paint was quite a thing for them, and they said it was quite a challenge because certain vehicles with the premium end, it was very challenging to get the finishes they wanted with that type of paint. So, but interesting stuff. Thanks, Sebastian. I think what we'll do now is invite Henning and Klaus back onto the screen. So I will just I want to just say to the audience, we've already got some questions coming in now. Please keep sending your questions for our experts. We'll just move into sort of Q&A session. This is looking at things in more broad terms, not just obviously from your own experiences and your own insight, but how you perhaps see the industry going. I mean, one of the things I'm kind of alluded to a little bit, where you see the next steps being taken in making the paint process more sustainable. And you mentioned that it's an ongoing process, relatively small changes, fine tuning of operations. And I wondered, and again, Sebastian, you can comment on this as well. If you saw it being that fine tuning, so kind of small steps, or whether you saw the need, or will see the need once you've reached the kind of limit of that, of the requirement of new technologies in certain areas that speed up curing, as Sebastian was talking about there, application. Do you see the need for big steps coming in the next few years, and especially looking at the generation of vehicles that are coming through, or is that not what you expect? So Henning, do you want to field that one first?
Yeah, I personally don't see the need for big steps at the moment, to be honest. It's material development, application development, but I'm not quite sure whether I see the imminent need to have a big step in any given area. I'm sure the electric vehicles will have new requirements with regards to temperatures in certain areas of the vehicle to make sure that the E-code, etc., is fully baked and stuff like that. But it's more an evolution than a revolution to me, to be honest.
Sebastian, your views on that? Do you agree with that?
Yes, there is no revolution. I think that there are some new needs which are in the continuous of the existing things. We see a lot of electric cars being with a black roof, especially in the Volkswagen group. So it's a more and more two-tone application. So it was already done many years ago. So we have to increase and make it more industrial. And the other thing I think for electric cars is that we have new process for the all around the battery pack and all the electrical packages which are embedded. And sometimes, depending on each OEM, they are not put in the factory in the same process. So we have to adapt, and sometimes it's outside of the trim shop, sometimes it's inside, sometimes everything is done by partner. So different typology of process for that.
And it brings, I mean, I was going to ask about this. Do you see, not, I mean, obviously you're starting to produce the electric Macan in the near future. Looking at, and again, looking around at where electric vehicles are going, the kind of architectures, platforms, and I'll come on to the battery pack in a minute. Do you see, what impact do you see in the paint shop that these changing architectures might have? And by that, I don't mean just the sort of shape, I mean kind of the composition. So we're seeing sort of lots of, well, like multi-material vehicle bodies. So different steel grades, for instance, where they're using high and low strength steels, which obviously from a thermal management, when you're kind of drying them, have some issues. You get hot spots, something heats up quicker than the other. But also the use of aluminiums and things like that, where you're getting a mix within a body shop, or potentially getting a mix. If that's not necessarily the case with Porsche at the moment, but looking at around, how do you think that will impact the paint shop going forward?
We see it with some of our current models already. We need to keep in mind that the multi-mix vehicles, like our Panamera, for example, which is running alongside Macan, which is a full steel body, there's quite a big difference in heat expansion during our oven process. So that's one area where we had to learn a lot over the last couple of years. I think that will continue to be a big not a problem, but a challenge really, to make sure that geometry-wise, once the body shells leave the paint shop, they are still what they're supposed to be. That's certainly one area where we are still progressing, which is not in general a paint shop issue, but it's something that we need to keep in mind when we design our process and look at different temperatures in the ovens and energy reduction activities around that. That's one thing. I think the new platforms are giving us an opportunity really to use a new technology that we've just introduced actually in our paint shop. So plugs versus pads or stickers, if you like. So in the past, most bodies had to have the access holes covered with plugs that are manually applied by an associate on the line. We have now started using an automated process, which is using round stickers really, pads that are being applied automatically. That is a good opportunity with the electric cars, because the underbody is flat. You don't have a gearbox cavity, and therefore you have a very flat and accessible underbody area. That's one thing that we really see as a big change with regards to electric vehicles and opportunities for streamlining our process.
Sebastian, do you see coming forward?
Sorry, could you repeat?
In terms of, from your point of view, I mean, is the equipment largely going to be the same that's delivering and applying the paint? In terms of sealants, you mentioned there, and obviously around batteries.
In electric vehicles, as we don't have any more the noise of the thermal engine, the quietness inside requirement is higher. So we need more sound deadener application, and for one decade at least, we provide some pumping and application with robots of liquid applied sound deadener inside and inside the paint shop, but also inside the body shop. And as it is flexible, already flexible thanks to the robots, if we need to put more, it's the equipment is available. The change was that the material, the latest materials are very abrasive and waterborne, so the equipment has to adapt to resist all that. And but it's done, it's already validated and used, so we can follow that. And in the battery package, there are new materials which were never dispensed by our equipment before, so we have to validate them, and that is where the relationship with the materials supplier is very important.
I mean, I'm aware that there's some very dense thermal management materials being dispensed in battery packs, which is kind of
the gap filler is the most difficult application.
And also, I mean, the battery pack itself, I'm assuming that there won't be. Is it a painted item? Is it just a coated item? Does it just go through a phosphate treatment to make it corrosion proof? Or because that is a key thing as well. There's the integrity, long-term integrity of these of those particular units. I'm sorry, I apologize. It's the battery boxes do seem quite a challenge, and also where they're located, they obviously get a lot of punishment from the environment. So there's a key thing about making sure we don't see corrosion in vehicles now because of the levels of coating now, how efficient they are, how effective they are, grades of steel, etc. But is that another challenge with the battery box in the sense of not just the sealing of it, but the actual making sure that is as corrosion proof as the rest of the vehicle?
We see that there is some liquid coating used, some powder coating used as well, and high viscose material for adhesive or sealing, gasketing. So a wide range of equipment is used, and maybe Porsche will have a way to manufacture this, and another company, even maybe in the Volkswagen Group, may have another one.
And one of the questions
from our point of view, with regards to the battery pack, we just need to make sure the underbody is sealed off to the interior, but obviously the battery pack is not applied in our paint shop. It comes in final assembly with. So as on any other car, we need to make sure it's dry and corrosion resistant, and that's easy for us. We don't see big challenges in that area at the moment.
Well, one area, just one of the areas I wanted to ask about in terms of what are the biggest, aside from cost, which I kind of know we can probably discuss quite a lot if we wanted to. What are the biggest challenges and barriers in making paint shops more sustainable? I mean, does it to some degree the legacy infrastructure? Because a lot of paint shops are, you know, once you built them, they have a long service life. I mean, they're upgraded, but is that a particular barrier? And if that's the case, what are the solutions around that? Obviously, some paint shops have got a relatively new one at Leipzig, but some are quite old, and they're quite difficult to modify in some respects. Do you see what solutions do you see for that kind of thing? And is it a barrier?
It is a barrier, even though we have quite a new paint shop. As you said, 8 years is not a long service life for a paint shop. The problem is space, obviously. So once we build a paint shop, we don't plan in any spare areas really for future developments. So if we want to change anything big, it would mean it has to be outside of the normal production. So we run 5 days a week around the clock. There's not a lot of time to do any infrastructure changes, and we have a very limited time window in the summer shutdown weeks and in the winter shutdown. So it's space and time really to do it, and obviously the costs you already mentioned. So yes, it is a big challenge. So our hope is that any future improvements are so small and so easy that we can add them on a weekend, really. Would be perfect. So yeah, space is the biggest challenge there. But then also we build a paint shop to last for many decades, and we don't plan on building a new one just because the technology has advanced. So we need to find a workaround, really.
I wanted to ask the question going on to digitalization. We're seeing across other parts of the build of a car, that's helping quite a bit in terms of things like digital twins and simulations, especially in regards to planning operations and seeing throughput and efficiency. Is that something that you're utilizing or have been utilizing to, what you were saying there, you kind of got a fixed space as well, especially you don't want to build a new paint shop. In terms of optimizing what you have, bringing in new technologies, whether it be automation, sensors, etc. Do you use that kind of technology or have you been using that as part of the development process for your operations?
Yeah, we do use simulations for our new conveyor system. So if we add new areas, new automated process steps, obviously we need to make sure that the takt time and the overall jobs per hour are still working for us. So that's one thing we do. We do simulation on throughput, output, stuff like that. I think that's normal, really, but that's one thing that we use on a regular basis. We use simulations for heat distortion, as I mentioned, on the new models. So we cannot simulate a dryer or stuff like that. We can simulate how the materials and the mixed materials react to different process temperatures and stuff like that. Yeah, so we do use it not on a daily basis, but on a very regular basis, especially with new projects and new innovations coming along.
And are you looking to are you exploring more use of automation in paint shops? I mean, it is a very highly automated operation now, almost, I would say, probably 100% in most of the newer paint shops. You mentioned sealing earlier on, which probably was the last thing that was ever done manually. Now that's been replaced. We used to see occasional manual spraying as well in kind of the door shuts and areas, apertures where it was difficult. But now the robots are pretty much capable of doing that. But are you exploring any further use of automation within a paint shop? Is there any need for it, or do you see benefits in it? Because it's becoming quite advanced now in terms of its programming and its ability to be the software around it now.
One thing that we opened the door for really with the automated defect detection is automated rework. So that's something we are not planning on implementing soon, but it's something where we closely monitor the market and what the other OEMs and other brands in the VW world are doing. Because with the 3D detection and the robot-based sensors, we can quite easily then translate that into a rework instruction for a robot. So that's one area of innovation that we are maybe looking at implementing, or at least giving it a try somewhere. Another example could be inline thickness measurement of the paint structure. So we're looking at using the 7-axis robots in the defect detection takt to change the sensors or add another additional sensor on top of that one to then inline measure paint thickness from E-coat up to clear coat, to then use that information downstream, not upstream in this case, to closely monitor paint thickness and adjust and obviously reduce it to the least possible amount.
Okay. And Sebastian, is it something you're seeing more of? I mean, in terms of the equipment you're supplying into the paint shops, do you see, I mean, the sophistication of automation rather than more of it?
Yes, we did use more. We did put more intelligence locally in the automation of the sprayer. One of our sprayer for waterborne painting is with internal charge. The name is Acubel, and in this Acubel there is a servo motor with a canister, and the servo motor is dosing the paint sprayed by the sprayer, and we have the same canister with a servo motor to transfer the sprayer comes and dock to the second canister, and we transfer very fast the paint for the next car. And during painting, we can use the second canister to test and to check many valves. We push the piston, we close the valve. If the piston moves, that means that the valve is leaking. So we detect and we check many valves like that, between 3 and 5, depending on the process. And so automatically during the painting process, we are able to check the valves and the system. So it helps to be sure that the equipment is still available for production, and also it's alerting if there is a leakage, the operator to change the valve which is required. So he doesn't need to check to replace all the valves. So we reduce the running cost, and we reduce also the downtime. So it's automation very close in the equipment.
And something, I mean, alongside with automation, digitalization, data gathering, etc. There's one of the things that's been, the term that's been used in terms of this is the democratization of automation, in the sense that it can be used by all, it can be accessed by all in respect of that. And as we're seeing greater monitoring and management of operations and processes, and you mentioned there that within the paint shop, is that something that you're seeing? And do you need to develop more skills or bring in more skills into the paint shop, into the operatives there in respect of that? And are they being trained, or are the systems accessible to all of them within there to enhance their job?
I personally think that we need less mechanical skills and more obviously digital skills. IT skills is what we seek, and where we already struggle to find to meet every demand that we have. So that's probably one major step forward to make sure that we have the right sort of qualification with regards to all the digital processes, automated processes, to make sure that they're up and running. That's one area where we need to closely monitor and make sure that we have the right people and with the right skills with us. So it's IT and understanding of computer systems and stuff like that, what we seek even more.
And Sebastian, do you see the same thing?
For sure, we add more and more sensors everywhere. So the automation should be more and more smart to detect and to say to the operator what to do. But if we want to keep the high quality, I think we need also to keep some people in the paint shops who knows how the paint reacts, how the paint is sprayed, how it is, what kind of issues they may see, and how to solve them. Because sometimes it's coming from the paint, sometimes it's coming from the sprayer settings, sometimes it's coming from the circulating, or from the car itself. There are so many issues possible that local experience in front of the paint film is very important to keep. But for sure, it's very difficult. It's a challenge day by day, because this long-term experience is very difficult to build and to keep. So that's why also we are, as equipment supplier, we try to be as close as possible as OEMs to propose audit, training, partnership for issue solving workshops like that.
We've got time for probably.
Couldn't agree more with what Sebastian just said regarding sometimes paint is like black arts, so we need to have people who understand painting and have painted manually before. So automation is good, but at the end of the day, if the machine doesn't understand where it's coming from, you need people with lots of experience. Totally agree.
And if there was a defect in the paint, that's to identify that there might be an application issue or something like that, that they would have the experience to identify. Maybe it was a contamination in the paint, maybe it was something to do with pressure or temperature or something like that. You couldn't automate that. That wouldn't be. You couldn't. There's nothing that could recognise it. Because you mentioned you've got the camera system looking for defects, which is pinholes, dust, or dents. I'm guessing it's kind of fairly binary in respect of looking for those things. So you do need that sort of manual experience, those people. Yeah.
So, absolutely. So I think one step where we can use the data collected by, in your example, the automated defect detection is to understand, or maybe to have heat maps of areas on the car where we see paint defects of a certain kind. But once we have that information, I think it's going to be a couple of years yet before the machine will be able to give you exactly the reason for the defect. So that's where we need skilled and experienced people around us that then are able to integrate and understand what's going on really.
And then that visual inspection of paint finishes in paint shops, I've seen it over a few years being developed. I think General Motors had something a while back as well. And each iteration, they do get that bit more sophisticated and they get certainly more accurate, which is the key thing. They're picking up more of the thing. And now I'm thinking we discussed it on other live streams, is the use of AI and the algorithms. They're much smarter now. They can almost adopt quite a lot of the knowledge that's coming out there. They're much more nuanced in their analysis of visualized images in terms of what they're seeing. So again, you kind of watch this space with that, see where that goes. But I've got probably time for just one last question before we close the session. So I'll go to you first with this one, Sebastian. This is kind of like a crystal ball thing. What if all your Christmases came at once? What would it be? What's your vision of a best-in-class paint shop in the next sort of 5 to 10 years as a supplier? One that I'm assuming uses a lot of Samer's equipment is one thing. We'll get that one out of the way first.
I have a dream.
In terms of what do you see, like if you're ironing out all the issues that are there now, what do you see as the kind of optimized paint shop in the next sort of 5 to 10 years?
I think the future of painting process will be less oven as possible, with lower energy consumption of these ovens. So either we can take green energy to dry our cars, but not sure that the warming climate is enough. So we need more new chemicals for drying fast and at lower energy cost. And for sure, the waste is not acceptable anymore everywhere. The waste of water, the waste of energy, the waste of paint, the waste of for the two-tone application today, as you mentioned, a lot of paper, plastics, tapes are used. Tomorrow it will be print, so we don't print out of the area we need to print. So it's a huge step forward. The big challenge will be to print everywhere on the car, which is in some area very challenging. So we start with the roof, okay? We will go very soon on the vertical surfaces, but exterior body. We will work, of course, on plastic parts to print. But after, to go inside the opening of the door, it will be a new challenge for that.
And Henning, do you want to just add your what if you had your choice of what your paint shop would look like in 10 years' time? What would that be?
I think Sebastian mentioned the most important points. It's basically a closed system with no real waste, low energy consumption with new materials, maximum amount of help by automated systems, and a minimum amount of manual rework, really. So we can have a very lean and green process, really, in the end.
Well, I'm sure we'll get.
You mute your mic, Nick.
I know, yeah, I always do that. Thank you very much for your time, gentlemen. Much appreciated in your insights. It's been really good, really interesting to get that. So that's all for today's session. We'll pass on all the questions we have now to the guys we haven't had a chance to answer. Just as a quick mention, again, thanks to our partners for this, Jayco Tarkisha and Summit Kremlin, for their support with this live stream. And we just to reiterate, we have our Evolution Summit coming up in December. So as I mentioned earlier, if you would like to join us, free to register, and we'll be covering a very broad section of the automotive manufacturing operation. And if you want to access the recording of this live stream later on, if you didn't have a chance to watch it, all of it, if you want to pass it on to your colleagues, you can access this and all the other live streams on the Spotlight section of the AMS website. So with that, I'd like to say thank you very much for your time and joining us. Thanks to our expert panel, and we'll see you for our next live stream in due course.